Good morning, everyone. Myself, Yash Vyas. I am a student of IIPS BVV and currently in 4th SEM. And today I am going to show the solution of internal 1 assigned by Professor Dr. Saligram Prajapat sir. In the first question, we have given a system of simultaneous equation ax plus by is equal to c plus px plus qy is equal to r. And the given table show the values of p and abcd and pqrs in different cases and how the change in one value can affect the value of x and y significantly. For example, in case 1 and 2, a slight change of 0.001 in the value of q has a significant change in the value of x, as the value of x was initially 0.9997 and in case 2 it becomes 0.999 0.1.0009, and this illustrates the system of equation is sensitive to propagation. And in case 2, 3 and 4, equation swapped, x and y value interchange, and swiping equation does not change the solution but may affect the numerical stability. The C0 coefficient algorithm must check if the demonstration D before division flag has no unique solution, parallel or coincides. Now in the algorithm, we are firstly taking input the values like A, B, C, D, P, Q, R, and then we compute the value of D, which is equal to A into Q minus B into P. And if D is equal to 0, we print no unique solution and stop. And but if D is not equal to 0, then we check the value if A, P, C and P, Q are equal to 0, write warning, else we will compute the value of dx, which is equal to cq minus br, and compute the value of dy, which is equal to a into r minus c into p. Then we will compute the value of x, which is equal to dx divided by t, and compute the value of y, which is dy divided by d. And we will print the value of x and y and stop. Same for the algo, same as algo, the flowchart also show the following steps and which are similar as the algo. Now we will solve. Now we will show. I will show the solution of question number 2. In question number 2, we have given an equation x square plus 2x minus 2 equal to 0, and the equation has the value of a is equal to 1, b is equal to 2, and c is equal to minus 2. Discriminant is equals to 12, and under root of discriminant is equals to 3.4641. It is 4-digit mantissa. Now in the case 1, we can see the value of uh, x square plus 2x minus 2 is equal to 0. Group polynomial terms, and when we compute the value from this equation of x, then we will find the x1 is equals to 0.7321 and x2 is equals to 0. Minus 2.732, where x1 and on checking the value, on checking or suitability x1 square plus 2x1 minus 2, we will get the 0.536 plus 1.464 minus 2, that is equal to 0, and same for the below. And then we will check for the case 2. The reordered linear term first comes. So on this, we will getting the value of x1 as minus 1.366, the alternate formula, using the alternate formula, and the value of x2 come as 0.3660. and we can see that both are wrong if a native grouped used use standard quadratic formula for accuracy. The key insight from this is that the standard quadratic formula is, is this, and the cancellation error b and d are nearly equal, and the subtraction cause loss of significant digits. The alternate formula for this avoid the cancellation of for one root, allow verification for suitability back into the equation. Now this graph shows the variation in both the cases. Now the question number 3, polynomial equation, Horner's method versus brute force. The equation P of x is equals to an into xn plus an minus 1 into xn minus 1 plus and the last term for this equation is a1 x plus a0. The n degree polynomial and n plus 1 coefficients are there in this equation. The computational effort compresses method, brute force method, we are manually doing the everything. The multiplications as n plus 1 by 2, which is approximately n square by 2 for large number, and addition it is n for total ops is equals to big O of n square. The efficiency is poor, but in Horn's method, recursive method, the multiplication is n, addition n, and the time complex total ops n, efficiency is optimal. The Horn's method says that the initial b n is equals to a n, the recursive a b k is equals to a k plus r into b k plus 1 for n is equals to n minus 1 to 0. The result p of r is equals to b0, the quadrant polynomial coefficient b1, b2, bn. Explain example, the x cube minus 6 x square plus 11x is equal minus 6 divided by x minus 2 is equals to r, and the solution is given as b3 is equals to 1, b2 is equals to minus 4, b1 is equals to 3, b0 is equals to 0, and the quotient is equals to x square minus 4x plus 3. Now this graph shows the uh, time consumed in the brute force method, which is represented by the blue, and the time in the Horn's method, which is represented by the green. The computational representation polynomial analysis, the Horn's method saves 50% operation versus the brute force method. The algo for the Horn's method is input the array A, comma, n, comma, r. If b of n is equal to b a of n, then k is equal to n minus 1. Then check for the if k is equal to 0 less than 0, then output is equal to b of 0 is equal to tr and stop. But if k is greater than 0, then bk is equals to ak plus r into b k plus 1. So k is equals to k minus 1. And that's the answer. Now I will explain the question number 4, which says the compare the iterative methods of root finding methods. In this way, we have bisection, regular falsy, Newton-Raphels, secant, and fixed point iteration method. Firstly, we are comparing the formula of all of these. The bisection method, the xm is equals to a plus b by 2. In regular falsy, the x is equals to a minus b f of a b minus a divided by f of b minus f of a. In the Newton-Raphels, m is equals to x naught minus f of x naught divided by f dash x naught. In secant method, it has the same formula as the regular falsy, which is x minus f of x1 into f of x minus 1 divided by f of x1 minus f of x2. In fixed point iteration, we have formula xn plus 1 is equal to g xn, where f of x is equals to 0 and x is equals to g of x. The convergent order for the methods are bisection method, it is 1, linear, regular falsy, it is linear, in Newton-Raphels it is quadratic or 2, and the secant method it is around 1.618. In the fixed point iteration it is 1. The reliability, in the comparison of reliability, the regular falsy and bisection method are reliable, while the Newton-Raphels and secant method may deviate, and the fixed point iteration converges only if when mod g dash x is less than 1. Now the requirements for the followings are: f of a dot b, f of b is less than 0. In Newton-Raphels, f of a dot f of b is less than 0. In Newton's Raphels, f dash x is not equal to 0 with initial point guess. In in the secant method, two initial guesses are needed, and in the fixed point iteration, the g dash x mod must be less than 0. Wow, on the comparison of the speed, the bisection method is slow. The regular falsy is faster than bisection, but the Newton's Raphels is the fastest method, and the secant method is not fast needed, and the iteration method depends on the value of g, so it is moderately fast. Now this graph shows the convergence rates of the all of the following. The red one is the bisection method where the convergence order is equal to 1. The green one is Newton method where the convergence order is 2. And the blue one is the secant method where the order or convergence is 1.618. Now the question number 5. Associative and distributive law for four mantissa digits. We have given an equation a plus b minus c, where we have to prove that it is not equal to a minus c plus b, where the value of a, b, c are the following. Now we will first calculate the LHS for this normally, where we will find the final value as 0.0770, and then we will do through RHS. We will find the value of RHS, and where we will find the final value as 0.07656, and we can clearly see that the RHS is not equal to the LHS. Hence the associative law fails. Now for the distribution law, we have equal a b minus c as LHS, and the final value of LHS is 0.0005555. And since we have 4 digits, so we will only see 4 digits after the mantissa, and on the RHS side we will find the answer as 0.0006000. So the final answer is 0.0006. So on comparing both the LHS and RHS, we will find that the it doesn't it are not equal, so distributive law fails in this. Thank you.